resource utilization. Now, up until now, a lot of times customers would complain that they are not achieving a particular test configuration to its full performance because the test tool is not able to do it. And there was most of the times there was no way for us to prove whether it's a test tool or the TUT itself that doesn't have the resource capability to achieve a particular test configuration. With 8.50, when you click the resource tab, we are introducing two new KPIs that will talk about the network processor usage and memory usage of the test tool while running a test. So you would be clearly know whether the test tool can or cannot achieve a particular performance. Let's do a quick demo to better show the usability of this feature. Now I'm in a breaking point test that I have configured. In this test, there is several superflows that is performing an ECDHE handshake, and I've started this test with 1000 sessions per second. Everybody would be doing, each of them will be doing ECDHE handshake. So very CPU intensive test. So I'll let this test start and run. The test started running and we see it's getting some performance. Let's move to this tab, resources tab, and you can see this processor usage and memory usage. What you see here is the different processors. So SC is system controller, is the controller of this perfect storm. We are using a perfect storm unit here. The network processor is actually the test processors, and we see that the one network processor is achieving around 60% processor. It's reaching around 60% processor, so we know there is some headroom. The system controller is using 48% of the memory. That's usual. The network processor doesn't use a lot of memory, which kind of makes sense because this is not a memory test. It's a connections per second test, and we have very low concurrent flows that would have generally spiked up the memory. Now the big uh, value add that we find from this is that the resources utilized for this particular test is 60%. That's a very good indicator of how much this test tool can go. So for example, one network processor could do at 1000 sessions per second would go for around 60%. So to fully use it, maybe I can go for not full 200 flows per second, but 2000 flows per second, pardon me, but somewhere around 1800 flows per second. Maybe that would let the network processor get fully consumed, and we can utilize this device better and get the max performance out of it. So I have changed the test to now trying to achieve 1800 sessions per second, and we will see how that affects the test. So the test starts running and I see it's achieving a 1800. I can verify that these are all SSL sessions. It's 3600 because in this particular page we calculate both the client and the server side of the handshake. Let's move to the interesting part, which is the resources. And as we had thought, it actually reaches somewhere around 91-92%. That's where we know that this device can do only a little bit more before the whole network processor would be consumed, and we generally recommend not to go beyond 92-93% because at some point of time might start losing packets. So that's good. We could do 1800. That's a very good indicator based on if 1000 sessions were with 60% CPU, with 1800 I'm getting 91% CPU. But as you know, we are using a perfect storm, a full perfect storm blade here, and it has two network processors. And as per our design, one component can only use one network processor. That's why you see only one network processor being shown. So how do I fully utilize this perfect storm? We have to add two components. All I will do is add a duplicate of the same component, and ensure that we have two components. And now if you see the total session flows per second we are going for is 3600, and hopefully this will use both the network processors at its 90-91%, and we achieve the maximum performance. Okay, so the test again starts running. We see it's initializing now, and the test starts running, and we see the processor going up. And now if you see, if you remember earlier, we were only shown NPO, and now we see both the NPs. Okay, we'll remove the system controller, and both the NPs moving to achieving somewhere around 91, 92%. And if we see the summary, we are achieving 3600. So this is probably the max that our tool can go at this particular rate. And we see all of them are getting successful, and there is a lot of applications. It's quite a complex application. Of course, if we change the test configuration, we can go higher or lower. At least we know for this configuration, 3600 is a sweet spot for perfect storm. And if, let's say, the device under test is doing only 2500, then we can always tell the customer that we have leftover CPUs. It's probably blocking at the device side, and vice versa. If the device is doing 3600 and that is not skipping a beat at all, then we will say that the test tool has already been overwhelmed, and you need to add more test resources to completely overwhelm the device. So let's get back to the presentation again. We support this feature from 850 onwards. We will also publish this in the reports. If you see this screen at the right side, it will be published in the reports section. We do not support runtime fetch of the stats through TCL or REST API, but we plan to add it in near future.